All right, so we have talked about parallelograms. We have talked about rectangles. We have talked about rhombi, which is plural for rhombus. Today we're going to talk about square. We still have trapezoids and kites that we're going to do tomorrow and Friday. We review Monday, Tuesday. We test on Wednesday of next week. It was supposed to be Tuesday, but since we had an extra day, or we needed an extra day, we pushed it to Wednesday of next week, okay? Squares are the most specific type of quadrilateral there is. You've got your quadrilateral, those are four-sided figures, and you've got your parallelogram, and then under parallelogram, we've got rectangles, rhombi, and squares. So, if you notice, it says in that first sentence that squares have all of the properties of a parallelogram, a rectangle, and a rhombus, okay? Squares have all of the properties, and there is a list there. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, the diagonals bisect each other, you have 4 right angles, all 4 of your sides are congruent, your diagonals are perpendicular, and your diagonals bisect all the angles. Okay, so that's a lot of properties for a square, right? Everything we've learned falls in that category. To me, squares are usually one of the easier ones to deal with because it's very straightforward, especially when we get to our angles. So let's start with that first example down there. It says that EFGH is a square and that FJ is 19. We want us to find FH. This is actually a really easy question. You should be able to do this without my help. Label what it tells you in your picture. It tells you that FJ is 19. It wants us to give FH. What is FG? Is it part of my side, part of my diagonal? What is it? I'm sorry, not FG, FJ. I said the wrong letter. FG is a side, yes. But FJ is part of my, segment diagonal. And it says that it is 19, and it wants to know what the whole thing is from F to H. The diagonals do what to each other? Bisect. So if the top part is 19, what's the bottom part? 19. So what would the whole thing be? 38, right? That one was relatively simple. You didn't have to do a whole lot of work for that. All right, read through that second example while I'm finishing passing these out, please. What shape does it say that PQRS is? A rhombus. Okay. So let's look at our picture. It tells me that PQ is 4x plus 3. So the first thing we want to do is label that. PQ is 4x plus 3. It tells me QR is 41. And it tells me that the measure of angle PQT okay, we're going to hold off on that for just a second, that second part of the question. So do you notice how where it tells me that PQT, it says 2x plus 4y? It's got 2 variables in it. Can we solve equations with 2 variables? Not unless I have two equations. So what we're going to have to do first is use the first part that they gave us about PQ and QR and figure out what X is. What do we know about all four sides of a rhombus? They are all congruent. So if I know that PQ is 4X plus 3 and I know QR is 41, what should I do to be able to solve for X there? Set those what? Equal to each other. So go ahead and do that. Write your equation. Go 4X plus 3 equals 41, and go ahead and solve that for X for me, please. This is a two-part question, and we really do have to think quite a bit about this one. This one would be more like a bonus level question, I think. A little bit more on the challenging side. What do I do first? Subtract the 3. All right, so I get 4x equals 41 minus 3 is going to be what, 38? And then we're going to divide by 4, and I don't think that goes in evenly. Tell me what that decimal is, please. 9.5? Thank you. All right, everybody okay with how we did that? Now, before we move into the second part of my question, let me ask you this. Talking specifically about squares, what are all four of my angles in a square? Right. Okay. And then it tells me that when I draw my diagonals in, that I cut those in half. What's half of 90? 40. So that means each one of these small angles, if this is a square, will always be 45, okay? Because you always have right angles, and if that diagonal comes through and cuts that in half, each of those is going to be 45. Anytime you have a square, it will not change. That's the only shape it will not change on. Understand that so far? Okay. So what we want to do now is we want to look at what it's asking me. It is asking me to say, let's see, hold on, PQT is this angle right here. I'm going to write it above because I don't have enough space there. My picture's not big enough. Is 2x plus 4y. Okay, that whole angle right there. Does that make sense? Okay. What it says is what should the value, or what does the value of y have to be for that rhombus to actually be a square? Okay. So if it is a square, how much does that angle have to be? 45. Okay. So this is what we're going to do. Is we're going to take that 2x plus 4y, and we're going to set it equal to 45. Okay, because in order for it to be a square, each of my big angles cut in half. Half of 90 is always 45. However, I still have two variables there, correct? But I know what x is, so what should we do with that? Plug it in. So let's do that first. We're going to go 2 times, but instead of x, we're putting what we got for x, which is 9.5, plus 4y equals 45. Is everybody okay with where the 45 came from? Okay. I'm going to come over here to the side. What is 2 times 9.5? 19. Okay. So that's going to turn into 19. That's probably about to cut off, isn't it? Hold on just a second. I'll try to connect it. So you're going to change that 2 times 9.5 to 19. And then we can bring the rest of it over. Plus 4y equals 45. What I would like for you to do is finish that. Solve that final equation. And that would give us the answer of what y would have to be in order for that rhombus to become a square. Again, this is a two-tiered question. I will give you one of these maybe as a bonus, not as a regular question. However, this would be a question that they would probably throw at you on the EOC. What do I do first to solve this equation? Subtract 19. What's 45 minus 19? And then we divide both sides by 4. And so what is y? There you go. Anybody have any questions? A little bit complicated, but you got to just take it one step at a time. Say that one more time. Yep, that was the answer. It was asking what y should be in order for that to be a square. All right, I want you to try that next example. It tells me A, B, C, D is a square. What I want you to do for now, I'm going to give you a couple of things to skip. I want you to skip AC right now. Don't do that one. And then actually leave those 3 blank. Do BC and do all the angles. You should be able to do that based off of what we just talked about. Okay, you can leave AC, BD, and EC blank. We're going to get to that in just a few minutes. But I want you to try to find BC and then find the measure of all of those angles that I just talked to you about. That's going to be all. This square has a property of all of it. So what we just talk about angles in a square. All 4 or what? And so if you cut it down to the diagonal, so that means all your little ones are all the way down. The 11 has nothing to do with the angles. Not necessarily. Depends on which ones they are. All these little ones are 45. These are not 45. What does it tell you about your diagonals? So in the middle where they meet, those would be 90. There's nothing set up. You just answer your questions. Here is AB. Follow your letters. Start at D, go to A, and then do what angle. No, we're just on an angle. Your angle is what's in the middle, so that angle is this whole angle. There you go. That particular one, so you have to figure out which angle you're looking at. You have to go individually to see which angle you're looking at. You're talking about a big angle or little angles, you just have to decide based on the letters. Yes. In a square, we just talked about it. All 4 of my big corner angles are 90. My diagonals bisect those corner angles, which means all of these little ones are 45, right? All the way around my picture. And then what do we know? Look at that second to the last property listed under squares. What does it tell me about my diagonals? The second to the last one in that list. Look on your notes. Look at the top of the page. The second to the last one. What does that say? Diagonals are perpendicular. That means where they meet is perpendicular. So what kind of angles are all here in the middle? 90. That is going to be for a square, no matter what size the sides are, the angles in a square are always going to be that. You just have to figure out what angle are they asking you for. Okay, let's start with what they tell me. They tell me AD is 11, yes? So what would BC have to be? 11, because all 4 sides are congruent, right? Okay. And then we're going to come back to the other pieces. Let's look at our angles now. I am going to highlight it so you can clearly see where my angle is. We go by the letters. The first one is D, A, B. That angle that I'm referring to is the one there at A. Is it the entire angle or just part of it? The entire angle. So what would the entire corner angle of a square be? 90. Okay. Next one is AEB. Okay, AEB. If you're not sure, look at your picture. AEB was this top one right here. What would that be? 90, yep. The next one is CBD. Is that a whole corner angle or just part of it? Part of it. So what is that going to be then? 45, yep. Half of 90. And the last one they're asking us for is BAC. Is that an entire corner or just part of it? Part of it. So that's going to be 45. Okay, you have to be able to read those angles and know where it is. That middle letter is what you're looking at. It's just dependent on if it's the whole corner or just part of it or one in the middle. Is everybody okay so far? Okay, now we got to do a little bit of work now. We're going to look for AC first. So we know all four sides of this square are what? 11. And AC is going to be this diagonal here. Now, let's focus. What kind of shape is that? What kind of triangle specifically? A right triangle. So I'm going to draw it out here. This is bringing back to what we had to do a little bit yesterday. This side is 11. This side is 11. I don't know what that is. Remember, with a right triangle, we have to set up the what? Pythagorean theorem, yes. So decide what your C is. Remember, C is across from your hypotenuse. Which one is my C in this picture? Look at the little picture I drew. Which one is C? X. Okay, so what we're going to do is we're going to say 11 squared plus 11 squared equals X squared. Eleven squared is 121. If I add that together twice, I get 242. When you find the square root of 242 in your calculator, let's round to the first decimal place. Okay, everybody in your calculator, do the square root of 242. Round it to one decimal place. What did we get? 15.6. Does everybody agree with that in the calculator? Did we all get that number? We need to make sure we know how to do square roots in this calculator. You hit second, you hit X squared, and then you enter your number. So what is AC going to be then? 15.6. Whoops. And BD is my other diagonal, isn't it? And what do we know about the diagonals in a square? They are congruent. So if AC is 15.6, then BD is 15.6. And then the last piece they want is EC. Is that the whole diagonal? No, it's just how much? Half. So take your 15.6 and cut it in half. Divide it by 2, and that would give me EC, which would be, yep. If you don't know your properties, you're not going to know how to approach these problems. On Monday, when we started our review, I have a little, it's a two-sided paper. One is like a chart, and it has all of the properties, and we're going to go through and X out which ones go with which shapes. And then on the back, it has a flow chart showing you which shapes belong in what area. We're going to fill that out on Monday. you're going to hang on to that and be able to use it on your test on Wednesday. So as long as you fill it out properly, you will have all of the properties right in front of you. Does that sound fair? Instead of having to remember them all? All right, do that next example. We did some like this yesterday. It tells me MNOP is a rhombus. It wants us to find MP. You gotta first find X. If you're not remembering your rhombus properties, you can flip your paper over. They're on the front side. What does it say about all of the sides of a rhombus? They're all congruent. So set up your equation to solve for X. And then once you find your X, you're going to plug that back in to find the length of MP. I set up your equation to solve for X. Once you have that X, you are going to plug that back in to find the length of MP. MP is going to be the same as any other side in that rhombus. So in a rhombus, all four sides are the same. Yeah, it's going to be the same as this, yeah. So if you can find X and then plug it back in, that'll give you what MP is. What do you know about these two?
Right. Equation.
They equal each other.
That's all we know.
This is this. Yep, now solve for X first. Did you finish it? What do you know about the sides of the rhombus? They're all the sides of the rhombus, they are all the same. So set those two equations, so those two sides equal to each other. And then solve for X. What is it that we know about all four sides of a rhombus? They are all congruent. Thank you. So that means I can take this side, MN, and I can set it equal to the other side that I have. It doesn't necessarily have to be opposite sides, but that's what they gave us. So we can set up our equation. We can solve this for X. Once we have that, we can plug it back into either of my sides because all four are going to be the same. I'm going to start by subtracting my smaller 3x over to my 9x. Then I'm going to add my 77 over. So 6x is equal to, what is that, 84? And then we're going to divide both sides by 6. So what is x going to be? 14. Now that's not my answer, is it? That's what x is, but they want to know what the length of a side is. You can choose which one you want to plug it into. Would you rather plug it into 9x minus 77 or the smaller numbers 3x plus 7? I personally would choose 3x plus 7, but it really doesn't matter. So we're going to go 3 times, but instead of x, we're putting what we know x is, plus 7. 3 times 14 is 42. Is that right? Okay, and 42 plus 7 tells me that MP is going to be how much? 49. Everybody kind of okay? All right, we got one more. It tells me in this picture that CDEF is a rhombus. And it wants me to find the measure of angle FED. So we've got a little bit we've got to do here first. What I want you to do first is think about how can we solve for x here. Okay, think about how we can solve for x. What is it that the diagonals do to the angles in a rhombus? Bisect them. So look at your two angles. You have 5x plus 1. That's the angle on the top. The angle on the bottom is 8x minus 20. What do you know about those two? If the diagonals cut the big angle in half, what do you know about the two smaller pieces? If my diagonal cuts my big angle in half, what can you tell me about the two smaller pieces? They're congruent. So you need to set up your equation. Take those two angles, set them equal to each other, and solve for x. That is our first step. I need everybody working that equation. You're taking those two small angles and you're setting them equal because the diagonals bisect the angles. Solve it for x, and then you can pause there. Setting up our equation, 5x plus 1 equals 8x minus 20. We're going to work on solving this equation. I'm going to take my smaller x and subtract it over to my larger x. 8 minus 5 is 3. Then I can add my 20 over. If I get 21 equals 3x, I can divide that by 3, and that gives me x equals 7. Okay. Now, that is not my answer. That is not even what I'm looking for. But what I do have to do is think about what I'm looking for. So let's take a look at what the question asks us for. It asks us for angle FED. So I'm going to highlight that angle, FED. That's that big angle. Is that the angle that my other pieces are dealing with? No. Okay. So what we have to think about is, okay, well, what do I know about that angle? Think about my properties. I'm going to draw it up here without the diagonals for just a second so we can take a look. Okay, this is F, C, D, E. This is the one we're looking for. This is the one I have information about, right? Are these opposite angles that are congruent, or are they consecutive angles that are supplementary? Consecutive, okay? So I need to figure this one out. Do I have enough information to figure out this one? Yeah, we know what x is now, right? So let's plug that in. I'm going to start with here. I'm going to plug it into that one. Okay, so I'm going to take 5 times 7 plus 1, which gives me how much? 36. So if this top one is 36, because these two are the same, what would the bottom one have to be? 36, okay. So if I have two small angles here that are both 36, what would the whole thing be together? 72. Does everybody understand where 72 came from? Was that a uh-huh or a uh-uh? Right. Now that I know this angle, can I figure this one out? Yeah, we're just going to take what and subtract it if it's supplementary. 180 minus the 72 that we found there. And we find out that the measure of angle FED is, did you get the same thing? What'd you get? How'd you do it?
I know that you just did like the perpendicular ones with the right angles. So I just took E and I just thought she was 90.
It is. You can do it that way too. Yeah. Does everybody see what she said? She said she remembered that the diagonals were perpendicular. Oh, I failed. All right. So another way to do it, yes. If this is 36, the diagonals are perpendicular. We can find out what this piece is and then double it. You can do that. You can say 36 plus 90. Subtract that from 180. That is 54, which means that top part is 54. So together it would be 108. That one is the perfect way to do it as well. If I have any questions. Okay, these are specific to rhombi and squares.